Awesome. And Liz, how about your session?
Yeah, great question. I suppose if you are intrigued by the words eBPF, I mean, it's a bit of a buzzword term, and I hope that my talk will have given a little bit of an insight into what eBPF is, and particularly how we're using it to speed up networking, essentially by bypassing parts of the stack.
Perfect. And then let's get into specifically how you're using it. Why don't you describe, to people who are here and maybe we're listening to Gil, they may not have seen your session. Why don't you describe Cilium to the audience here?
Yeah, Cilium is a networking tool, a networking project that's based on eBPF. Cilium is part of the CNCF. We donated it to the CNCF beginning of this year, I think it was. Time is difficult concept. And it's mostly known as a Kubernetes networking plugin, a CNI plugin, although we do also have some users who use it standalone, particularly for load balancing. I mentioned CNCF, who are using it at amazing scale as a standalone layer 4 load balancer. Yeah, and it takes advantage of eBPF. I think one of the interesting things that I learned when I first joined Isovalent was the extent to which the folks who work on Cilium are deeply embedded in kernel development, but specifically on eBPF. So a lot of the time, the networking functionality, particularly that we've needed to build Cilium, has also required changes in the kernel. So I'm fortunate enough to work with some amazing people who are kind of driving forward eBPF capabilities in the kernel, as well as Cilium for networking.
Yeah, I was thinking about the days back when Kubernetes was used as a gimmick, was described as a gimmick or used as a punchline, right? But it was something everybody was talking about, but hardly anybody had been using in production. Were you always a true believer in Kubernetes, or how did you come to the Kubernetes? Because you have been working in containers before this, right?
Yeah. So I've been in the container space for long enough to remember the orchestration wars and was it going to be Docker Swarm? Was it going to be Kubernetes, Nomad, Mesos? There were lots of options, and I think the first KubeCon that I went to, which was in Berlin, was when I thought, oh yeah, Kubernetes is going to win this, because it wasn't just one organization pushing it. There were so many people from all manner of different companies who were really engaged with Kubernetes and kind of believed in it and building it. And that I think was what had really kind of convinced me that, yeah, Kubernetes is probably where I should place my bets.
So I was taking a look at your slides, and I want you to tell me more about packets of death. What IETF RFC are they defined in?
Oh gosh. I'm not so sure that there is if there isn't an RFC, maybe we should write one. Yeah, I think there's been 2 or 3 instances that have been, certainly I think there have been 2 that have been mitigated with eBPF patches. I couldn't tell you the CVE, but yeah.
So and then we have a question here from Brian Taylor. He says, I'm curious how consistently implemented the eBPF ISA is in practice. Do different NICs interpret programs consistently?
I believe they interpret programs consistently. Something interesting around this area is that the Microsoft team are implementing eBPF for Windows. And as part of that work, they're working with the kernel developers who've been working on eBPF. I mean, kind of reverse engineering. I mean, not exactly reverse engineering, but, figuring out, well, here's the instruction set for eBPF. Some of that is documented more in code than it is actual documentation, but they're trying to turn it into a more standard spec. So I think in general, it's pretty standard, and I would say, particularly when we talk about NICs, there's not that many different cards that support offloading, so I'm not aware of any incompatibilities there, but there could be, and I just don't know. So yeah, I think it's pretty standard, and we'll see more kind of concrete standards emerging based on this kind of collaboration with Microsoft, I think.
Okay. And then there's another question here from David. Let me just go back up to this. He says he was looking over the Cilium Bandwidth Manager. He said it looks great for TCP, but he was questioning about whether it's going to work well with UDP or QUIC. So what was your thoughts? Do you have any thoughts on that then?
I will defer that question. I will go away and find out and ask one of my colleagues on that one, because I'm not sure. Yeah.
All right.
Sorry, I don't have that on the top of my head.
Sure. No, I totally get it. But thanks for the question then. And then Liz, you are on social media, right? If they want to follow up with you. Okay. So you can tag Liz. Do you want to put your just your handle?
Yeah, I'm Liz Rice pretty much everywhere. So
okay.
Oops.
Fair enough.
I'm typing into some other random window. Yeah.
And then we have another question here from Bluent here. I have a question related to eBPF. It seems it can be used many different. It can be used in many different aspects, but I'm not sure what teams are focusing it. What types of teams are usually utilizing eBPF for successful projects? Security, network, server teams, etc. So where are you seeing this usage? And I think there's a specific Cilium answer, right?
Yeah, and I think there's a two-part answer to this. So the first is that eBPF programming rapidly becomes kernel programming. You know, I can do some demos around manipulating network packets, but at some point, particularly if we're hooking into sort of deeper into the kernel, and you can hook in anywhere, you start manipulating kernel data structures, and you kind of have to know what the impact of that is going to be. So with that in mind, there's a huge amount of excitement around eBPF, and I'm a huge believer in people, you know, learning to do some coding to get a real grasp of what's going on. That said, I don't think the majority of users are actually going to write a line of eBPF code. They're going to use projects and products developed by, you know, other organizations. So if I kind of put my Cilium hat on, so Cilium is primarily networking, but it's also offering kind of tools for observability, so you can see how your network's behaving, and security, network policy just being the sort of beginning of that. We're also doing some runtime policy things with a sub-project called Tetragon. And I would say that mostly when we're talking to users, they're platform teams. They might be network teams, but I think increasingly in the kind of Kubernetes world, people are starting to describe themselves as platform teams. And they're probably making a decision about a network interface. I mean, you can change your network interface, your CNI down the road, but that could be a little bit painful. So a lot of people want to make their CNI choice quite early on. And if they're thinking about what network they're going to implement, having these additional capabilities, you know, not just performance, but also particularly observability, I think really, it's appealing to a broader audience than just, I'm only interested in networking. It's also kind of, how are we going to use this and debug it? And you're not going to debug it by looking at eBPF code. You're going to debug it by using tools and looking at network flows.
Exactly. It's interesting. This is like, you know, previous pillars of observability were like logging and tracing and stuff like that. And eBPF is kind of like a fourth pillar to what you can do these days, it seems.
I think it enables a whole new set of tools. Yeah. I mean, we can, because we can hook eBPF into pretty much everything. And because you only have one kernel per machine, and that kernel's involved regardless of how many containers you have and how many pods you have and what have you, they're all sharing this kernel. So you can instrument that kernel once and get metrics or, you know, logs for particular types of events in this very efficient way. And we're seeing, you know, not just Cilium, but plenty of projects. There's probably 4 or 5 different projects now in the CNCF that are using eBPF, you know, for some kind of instrumentation. So it's pretty broad.
So let let me get into some of the, because the first thing whenever I hear of a new technology, one of the first things I do is I always think about the misapplication or the misappropriation of it. So isn't eBPF a potential foot gun where like you could really do damage? You were talking about being able to use it to reroute packets. So isn't that something that could be a security risk?
It's a really great question. I mean, with great power comes great responsibility. You really have to treat eBPF with the same care that you would treat root privileges. If you have the ability to load eBPF programs, you kind of have the ability to, do everything.
To run root. Yeah, exactly. Yeah.
I mean, part of that just is around like who has privileges in your system. Another related aspect to this is supply chain. I mean, everybody's talking about supply chain security, and there are discussions afoot on how we can sign eBPF programs so that we can prove their provenance is what we expect it to be. We do have the verifier, which is a nice let's say reassurance that what you're loading can't crash the system, at least, but you couldn't tell with the verifier whether it's a correct program but just happens to be malicious.
Exactly. So here's a question we had. It was actually addressed to Gil, but I think you might be the right person for this one. Is it possible to use eBPF within a managed Kubernetes service like AKS?
Yeah, so this is kind of a two-part answer. If you have access to the underlying host, then yes, you can. And if you can deploy privileged pods, then yes, you can, because you can then have the privileges to load eBPF programs. I'm not going to specifically answer the question there. I'm going to say currently, GKE Dataplane v2 is based on Cilium. AWS uses Cilium in EKS Anywhere. KubeCon is next week. And
stay tuned.
Yeah, stay tuned.
So one of the amazing things, because I went into, like, if people had open source repos, I wanted to go in and see how active they were, because sometimes these efforts are like the labor of love of one person, and sometimes there's a cast of thousands. In the case of Cilium, there are 482 contributors, and you're one of them. So would you like to give a shout out to any of the awesome open source contributors that you know to the Cilium project?
Oh yeah, I mean, there is a fantastic team. Isovalent is the company that originally created it, and I would shout out to all of them straight away, but more so even to the folks who in all kinds of different organizations. We've probably got committers from, I think, 6 or 7 different organizations. We have contributions from, as you say, hundreds of people. We really encourage that. I'm going to shout out again for KubeCon next week, because we have our first in-person Cilium project meeting. So if anybody is interested in coming along to that while they're at KubeCon next week, reach out to me on Twitter and I'll send you all the details. And we, as part of the CNCF, we get this exposure to an amazing community. And I think that's, the whole rising tide floats all the boats is been amazingly successful for projects like Kubernetes. And I think Cilium is another proof point for that model. Yeah,
so that gets into the whole concept of how do you govern. Like, this is a monster that's practically running away from you. There's so many people interested in doing this. So how, and you're part of the CNCF, technical oversight committee, right? And you're talking about, having these face-to-face meetings. What kind of governance is required to manage all of these, to herd all of these cats?
Yeah, so I'm actually no longer in the TOC. Oh, I did it for 3 years, and I felt like I'd done my time. So I stepped away a few months ago, but I certainly, have a lot of background there, and I'm still in touch with those people. Very, consider myself part of the TOC community.
An alumnus now.
Alumnus. Exactly. Yeah. The way the CNCF operates is not to dictate any particular governance, but we have kind of requirements around, well, you have to have a sensible governance model, and you know, we're not going to tell you how to hold votes or, you know, who needs to do what. We just want to make sure that it is, you know, community driven, that people can get involved regardless of, you know, where they come from or who they work for. And yeah, I think things like having a code of conduct and keeping people, you know, polite and kind, which we've been very lucky with. I think, you know, I guess, again, shout out to everybody who has set the tone in Cilium, because it's super nice, super sort of friendly Slack community, and very helpful. So, yeah.
Now, you bear a very rare title, Chief Open Source Officer. It's a rare beast these days. So make the case why more companies should add one to their CXO level titles.
Yeah, that's a good question. So, I mean, at one level, Isovalent was always a very open source focused company. So I didn't kind of come in and radically change the way that we operate in that sense. But I think the role of, I would say, partly is around how we interface to the outside world with the community-based work that we do, and advocating for that kind of open source community contributions that we continue to make. You know, sort of balancing that against the needs of running a successful business. And I'm a huge believer that you can do both of those things, that they can complement each other. And, you know, things like, how do we decide which features are going to be open source and which things we're going to, you know, retain for our enterprise customers.
Right.
And yeah, so there's a bit of a kind of product role, bit of, you know, I spend a lot of time interfacing with our marketing team on how we're communicating and you know, where we're going to be and where our community users are. And yeah, I think having the sort of voice of open source on your exec team maybe is sensible, good thing.
So we have a technical question here. Can eBPF also manipulate USB packets? Now, I think I know the answer, but what would you say?
Well, I'm going to say two things. So one is, I'm not sure whether there's anything like the kind of NIC offload that I described. I'm not aware of it. But as soon as there is an event in the kernel, yes, you can attach eBPF to it. So whatever the, you know, function call or stack or whatever the event is, we can write an eBPF program to attach to it. Exactly what you can do in terms of manipulating, you know, packets or data structures depends a bit on the kind of program and where it's attached. So there could be some like niceties to do with the way the USB stack runs, which I'm not familiar with, but I would say in general, we could certainly observe them. Manipulation depends.
And speaking about questions that you're not familiar with, I see that there's a question about SiliDB from the audience. Liz is an expert in many things, but probably not SiliDB. So if you have questions about that, we do have a SiliDB lounge, and I'd encourage you to go there if you have any specific questions on SiliDB.
I'm going to guess there are some experts here on that.
Yeah, we got some. You know, I want to go back to this, like you were talking about, you know, the coalescing around Kubernetes. So, but it's not just companies saying that they want to do something, right? There's usually like this key turning point when you see the technology for the technology's sake, not just the logos behind it, you know, because there's been many attempts over the years to launch, you know, marketectures that had all sorts of industry backing. So what was the technical attributes that you saw around Kubernetes that really said, like, this is working, you know?
Yeah, I suppose the fact that it was, you know, not just slideware. I don't really remember ever seeing it at a kind of theoretical level. I was, you know, when I was first seeing it, I was seeing Kelsey Hightower showing us demos and playing Tetris, and you know, there was something concrete there. You know?
Yeah, right, exactly.
Yeah, so I think that kind of real concrete demos, even if they were, you know, I mean, the early days, a lot of it was driven by Google, and they were basing this on the technology that they were using in house. So although it wasn't exactly the same as Borg, there was a lot of learnings from that, and I think that gave it credibility in the fact that you could just go and run Kubernetes and it would work. Was really powerful. I think at the time with the orchestrated wars, there was definitely I guess a usability issue as well. That I think Docker did a really amazing job of making containers easy to use, and then that orchestration layer. Sorry,
right? That was the other thing. It was that they were easy to use and performant, which was the killer for prior attempts at containerization. Right? You could put it in a container, but then gives away half your cycles.
Yeah, and actually kind of making containers sufficiently usable that I mean, I think when we first saw containers, people were kind of going, well, I'm just using it for the portability benefits, and I'm actually going to spin up a VM for every container, because that's, currently I'm spinning up a container for every workload anyway. Sorry, spinning up a VM for every workload anyway. So I'm using containers as a sort of distribution mechanism rather than a performance mechanism. But then realizing, oh, actually, these containers start up in the blink of an eye. This is, that's something we should be taking advantage of. And then that kind of fed back to the things that Kelsey was demonstrating with Tetris around bin packing and making good use of the resources that you have. So
right. Yeah. Now, but you also came from secure containers. So how did that focus on security help inform the work that you're doing at Cilium here?
Yeah, I got involved in security as a kind of almost like a byproduct of being really interested in how containers themselves work. And, containers are, I mean, depending on who you ask, they are or aren't an isolation mechanism. They may or may not be a security boundary, but they're certainly allowing you to isolate one process from another. And I think that kind of led me to being curious about, well, how secure is this, and what does that mean? And what are the, nothing is ever secure, but what do we need to do to break this particular boundary, or how many different ways can we break these boundaries? And I think from Cilium perspective, things like network policy, just being able to drop packets so quickly, it's a very, I actually had I was on a panel earlier this week, and there was a lot of discussion about supply chain security, which is hugely important, but it's all about, how do we detect vulnerabilities? How do we prevent vulnerabilities? How do we, update our, keep our software patched and up to date?
Right.
And then wait a minute, there's also this whole runtime thing, back in, if we think about patching, like, Patch Tuesday, we had firewalls, and a whole load of the defense we had was network related security tooling. And the same applies today, and even more so, because we've got these microservices. We can think about networking and runtime behavior in this like decomposed way. Like, who should my service be allowed to talk to? What other services should it be allowed to talk to? We see that with things like service mesh, and it's a really important part, a really powerful part of security that we almost don't. We're in danger of swinging too far, I think, to talking about just the supply chain aspects.
Exactly, because there's a blast radius. Once somebody, I mean, if people get access to eBPF, oh my God, the blast radius can be huge, right? So I'm old enough to remember when people were talking about like secure kernels and Flask way back in the day, right?
Okay.
So it seems to me that like this is a new boundary that people are going to have to create for eBPF, right? That we're going to have to come up with like, how do you manage who has access to do certain operations with a kernel and certainly not other operations. Like there's going to have to be, methods within these projects to really govern who gets to do this kind of stuff. And how does the system behave if, let's say, that you detected that there is some sort of unauthorized behavior? Did you just shut down eBPF? Well, what does that do to your operations, right? It's the kind of thing where it's not an easy binary. Oh, just shut it down. Well, that's like turning off the machine in Ghostbusters, right?
There is a kind of like what you'd call it, almost like a race to be there first. If you can use eBPF programs to observe and monitor other eBPF programs, so that can be a really great basis for security tooling. But you do have to know that you got there first, and that there isn't a rootkit that got there ahead of you. And again, that kind of speaks to things like the provenance of your eBPF programs and getting them from trusted sources.
All right, so Liz, you're more than welcome to stick around. We have Alex Gallego coming to the stage. We also have Peter Zaitsev from Percona. So if and we had one last question, if we can ask it here. Can an eBPF program be a kind of non-detectable?
Yeah, this actually speaks to rootkits. Yes, if you get there, if you're the first, if you get in there early enough, then yes, it is possible to mask yourself. That we had a presentation. I'm struggling to remember the speaker, but a presentation about eBPF rootkits at the most recent eBPF summit, and that was pretty compelling. So yeah.
All right. Well, stay tuned for more. Again, shout out to you, Liz. Thank you very much for being on our stage. You are going to be at you were saying KubeCon? No. What's the?
Yes.
It's KubeCon coming up. All right.
KubeCon in Detroit next week. Yeah, it's.
And one last thing, congratulations to everybody at Isovalent. I understand you guys just recently closed your Series B with Microsoft, Grafana, and Tomvest behind you. So I'm just looking for the wind in your sails over the next year.
Thank you so much. It's been an absolute pleasure being here.
Sure enough. Welcome to the stage, Alex. How you doing?
I am.